All right, so last time we obviously talked about systems of equations, and we focused on the algebraic methods to solve those, our substitution and our elimination. What we are looking at today are systems of inequalities. So these are where we have an inequality sign, greater than, less than, greater than or equal to, etc. All right? And the way that we solve a system of inequalities is by graphing, all right? So what we're going to start off with is just graphing a single inequality, just to kind of refresh our memory on doing that. There's a couple of extra things that we have to remember when we are graphing an inequality. So we are going to start this off the same way that we would graph a line, by plotting our y-intercept, which is 2. And then we are going to get a few more points on our line by using the slope, which is 5. So I'm going up 1, 2, 3, 4, 5 over 1. You could also go down 1, 2, 3, 4, 5 into the left 1. Now, before you, hang on, before you draw in your line, let's remember a couple of things that are special with an inequality, okay? We are looking for y values that are greater than this expression, okay? We are not looking for y values that are equal to that expression. So how do we show that in our graph, that we just want it greater than and not equal to? Colin? We'll get to shading in just a second. I just want to talk about the line, okay? We will talk about that. Alicia? Yes, so this is going to be a dotted or dashed line. And I always think it's helpful right next to it. Just kind of make yourself a note. Okay, this is going to be a dashed line. So you can line up your straight edge and just kind of dash that in. Now we need to call and talk about the shading. So I'm looking for y values, again, that are greater than this expression. So now we're going to talk about that shading. Which way am I going to shade, above or below, for this greater than symbol? Above. Okay, so just, you don't have to burn your pencils out, but just kind of lightly shade above that line, okay? And again, if you want to kind of make yourself a note, little arrow up to remind yourself we're shading above. All right, on the next example, it is given in standard form. Just for a little bit more practice, let's go ahead and turn this back into slope-intercept form. This works the same way as it does with equations. So we're going to start off by subtracting 2x. And then we'll divide everything by 3. Okay, before we even go to graph the line, let's think about what type of line it's going to be and which way that we will shade, okay? So, with the symbol greater than or equal to, what kind of line, dashed or dotted? I always say that, dashed or dotted, that's the same thing. Solid or dotted, what kind of line will we have? Kale? Solid, exactly. So, little solid line. And then am I shading above or below? Erica, what greater than or equal to? We're going to shade above. Okay, so just kind of some symbols before we actually go to graphing to remind us exactly what this should look like. So now we can plot our y-intercept at 4. Using our slope, we're going down 1, 2 over 1, 2, 3. You could do that again if you want. This is a solid line. And like Erica said, we're shading above. What questions do you have? Okay, so let's kind of now come back and review exactly what symbols give us solid versus dotted lines, what type of shading, and then we'll talk about checking your answer here in a second. If you have a less than or equal to, or greater than or equal to, because you have that or equal to, that is the reason why we have the solid line. If it is just less than or just greater than, we will have a dashed or dotted line. For our shading, we will shade above our line for what symbols? Emily, greater than? Very good. Greater than or greater than or equal to. And then we will shade below our line for either of our less than symbols. If you are unsure, if you have shaded correctly, you can always check your answer. The way that you can check your answer is to choose a point in your shaded area plug it into the inequality and make sure, do you get a true statement? So this, if you're unsure whether you've shaded correctly, choose a point in your shaded area, plug those coordinates into your inequality. Do you get a true statement? Here's what I mean by that. Let's go back to the first example. We'll just use this one to illustrate what I'm talking about here. So let's say because that slope is pretty steep, it might be hard to decide whether this is above or this is above. So let's check to make sure we've shaded this correctly. So let's pick a point in our shaded area, and it doesn't matter. Let's say, what is that, -3, 1. Let's hope we shaded this right. I did not check my work, so let's hope it's right. And then we're going to plug in these values, so -3 for x, 1 for y. We'll just plug those values into our inequality. So 1 greater than 5 times -3 plus 2. If you simplify that, is that a true statement? Cameron's shaking her head. So this would be negative 15 plus 2. 1 is definitely greater. Because we're getting a true statement, we know we've shaded the right area. Okay, so that's how you can always check. All right, let's get in now to our system of inequalities. Here's where you might want some colored pencils. So let's look at the first inequality. Ladies and gentlemen, is this solid or dotted? You tell me. Solid. So let's make a note of that. Am I going to shade above or below? Ladies and gentlemen, above or below? Above. Okay. So think through that every time. Now we can go ahead and graph this. Starting at -1, slope of -1. You told me a solid line. Now, lightly shade above. Let me know if you have any questions. All right, second inequality. Y is less than or equal to 2x plus 1. Megan, solid line or dashed line? Solid, and which way are we going to shade? Below, very good. Okay, so make those little notes to yourself, and then we can graph this one. Y-intercept of 1, slope of 2. And again, lightly shade below. What I want you guys to kind of look at as you are graphing each of these is where our solution sets are crossing. Basically, where do you see at this point both red and green? We kind of see both red and green in this area. So far, this is our solution set. But we still have one more inequality to graph. We have x is less than 1. Dylan, is this going to be a solid line or a dashed line? I can't hear you, honey. Yeah, dashed line. And are we going to shade, oh, this one's kind of different. Let's graph it first. So what kind of line is this? X is less than 1. What does that look like? It's vertical, okay? So we have a dashed vertical line through 1. Because it's vertical, we can't really talk about shading above or below. We talk about shading to the left or to the right for this. So really look at what your inequality is saying. Your solution are the x values that are less than 1. Where are the x values less than 1? Is that to the left of your line or to the right? To the left, exactly. So this one's a little bit different where we are shading to the left. Now, the last thing that I ask you to do, because I want to know that you understand exactly where your solution set is. Your solution set is where all of the shading comes together. So what I ask you to do is take like a black or really dark color and go over darker your solution set. Can you see where that is here? It's kind of hard to tell, but remember we're above the green line, below the red, to the left of the blue. Emily? It is in that really small triangle. So what I want you to do again, like I said, color that dark. That's your way of telling me that you know exactly your solution set. All right, let's try the next one. We have y is greater than or equal to 2. Levi, is this a solid line or a dotted line?
Solid.
It is. And if it is greater than, are we going above or below?
Above.
Above, okay. This is another kind of special one. This is a horizontal line through 2. But in terms of kind of shading, it doesn't really work any differently because we can go above or below. So it's just above that horizontal line. Our next one, y is less than x plus 1. Taylor, is this going to be a solid line or a dashed line? Say that one more time. Uh-huh. And are we shading above or below? Good. So then y-intercept of 1, slope of 1. And just be sure that you are doing the dashed line. Let me show you something real quick. Take one quick time out. Let's say that on a quiz or something, you accidentally make that a solid line, and then you're like, oh crap, because your colored pencils don't have erasers. If that happens, do this for me. Okay, that's gonna show me that you messed up and you realized your mistake, okay? So if you realize that that should be a dashed line, just kind of put some slashes through it. That will tell me that you know what it should be, okay? And then go below. Again, we're looking for where our shading overlaps. We see both blue and red below this line, but above the horizontal. So make that darker. That is your solution set. What questions do you have? Okay, we have just one more example then. Y is greater than or equal to 2x minus 1. Allison, is this going to be a solid line or a dashed line, that first one? It is. And will I shade above or below? Good. So y-intercept of -1, slope of 2. Braden, x is greater than 1, solid or dashed? Okay. And so this is another one that's vertical. So if we dash in that vertical line at 1, we want to shade x values that are greater than 1. So Braden, am I going to go to the right or the left? I want x value. Yeah, we're going to go to the right because we want x values that are bigger than 1 shaded. So I'm going to shade the big x values. And the last one, Mitchell, y is less than 5. Is that going to be solid or dashed? Okay, and which way am I going to shade? This is horizontal. Yeah, below. Horizontal line through 5. Oh, shoot. See, there I go. I mess up too. Just put those hash marks in. And then we're shading below. Travis, what's our final solution set? Do you know?
The triangle.
It is. It is that little triangle guy.